Hello class. In this lesson, we will be discussing about chi-square, which is the last aspect of test of statistical hypothesis. So if you're yet to watch the videos of the previous lesson, kindly make sure you do that before moving to this particular lesson, because we've been able to discuss the first two aspects of test of statistical hypothesis, which involve the t-test and the z-test. So this is the last type of test we're going to be discussing, which is the chi-square. Just like your t-test and your z-test, we also make use of chi-square to test hypothesis, that is the null hypothesis or the alternative hypothesis. So we want to know whether we will be accepting the null hypothesis or we will be rejecting the null hypothesis. So without wasting much of our time, let's move into what we have in this lesson. Chi-square. Chi-square is also a good example of test, or good type of test of statistical hypothesis. Test of statistical hypothesis. So in chi-square, just like your t-test and your z-test, you need to determine your null hypothesis and your alternative hypothesis. Just like your z-test and your t-test, chi-square also has a formula. The formula of chi-square says just s square, and this s square is your chi-square. Is represented with x square. So it says s square equals the summation of your observed value minus expected value all squared divided by expected value. Please take note that this square is only affecting the numerator. The square is not affecting your denominator. Please kindly take note of that. Your observed value are the values you are having in the table you are given, that is the data you are given, while your expected value are the data that you are computing by yourself. So without wasting much of our time, let's move into an example. So this example says, consider the table below showing the relationship between person's ability in mathematics and his or her interest in statistics. The table is given and it says take critical s squared as what? As 13.277. So you'll be given the table, but when you want to find solution to this, you will be computing your own table. You'll be having your own table from which you are going to be deriving your expected values. So the question says the test for independence between person's ability in mathematics and his or her interest in statistics using 0.01 level of significance. That's 1% level of significance and 99% level of confidence. And that's the very high level of confidence. So just like your t-test and your z-test, you need to determine your null hypothesis and your alternative hypothesis. Null hypothesis, in short, we can say our null hypothesis should be what? Should be that the ability in mathematics is independent of interest in statistics. And if you make our alternative hypothesis H1 to be what? To be that the ability in mathematics is dependent of interest in statistics. So we are going to learn now how to assess our bias hypothesis. So the next thing is now to compute our expected table. The initial table you were given, that's your observed table, but you have to compute your expected table. If you wish, you can firstly draw out the table you are given in the question before moving to the table from which you will be deriving your expected values. But without wasting much of our time, how we drawing that table, I'll just move to the solution. So our expected table will be looking like this. Here we have the ability, we have ability in mathematics, 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 which is divided into 3. Let me shift it here a little. Ability in mathematics. I'll be dividing it into 4 because we need to create a different column for your total. Ability in mathematics. Here we have this to be for low. We have this to be for average. And this to be for what? For I. Low, average, and I. So you can have this to be what? To be total. You can have this to be total. Then this represents our interest in statistics. Interest in statistics. Interest in statistics. Interest in statistics. So if we divide this into 3 each, let's divide this into 3 each. Here we have, let this represent this. Here we have this. And we have the last one. Then this can represent our total. We can have our total here, right here. And as you can see from the question, we are given here we have 50, we have 52, we have 15 here, we have 58, and so on. Then we've created a new column for ourselves to be our total. So we decide to input those values. We have it on the table. This here we have 53 here, we have 42 here, we have 15 here, we have 58, here we have 14, here we have 47, here we have 29, here we have 61, here we have 31, here we have 31. So we can now easily derive our totals. So if you add this together, 53 plus 58 plus 14, you should be having 135 here, 135. If you add this together, you should be having 150. If you add this together, you should be having 75. If you add 75. Similarly, if you add everything here together in the first row, you should be having 120. If you add everything together in the second row, you should be having 150. If you add everything together in the last row, you should be having what? You should be having 90. Likewise, if you add everything, all the totals here, if you add them together, you should be having 360. That means your overall total is what? Is 360. The overall total population is what? Is 360. If you add this together as well, you should be having 360 as well. should be having 360. That is, if you choose not to use this one, if you use this one, you should be having 360. You should be having 360. So I now decide to compute my expected values. I should now compute my expected values. Although I just have to redraw the table, but I won't be drawing the table again. I'll just be cleaning off those parts. But if you're doing it on your own, just try to draw the table and leave this space empty. Then you start computing, but you can try to compute all the totals, because no matter the calculation you do in each boxes, your total will remain unchanged. Your total will remain unchanged. So now let's begin our computation. So let's try to compute our expected values. Let's try to compute our expected values. Let's try to compute our expected values. So for this, what do you need to do? Just have to multiply your total here corresponding to the observed value here, and the total corresponding to the vertical, when divided by the overall total, which is 360. What am I saying in essence? For example, for this box, what do you have? 120 in the horizontal. What do you have in the vertical? 135. That will be 120 times 135 divided by the overall total, which is 360. So if you do it very well, you should be having 45. You should be having 45. So you are done with that. You move to the next box. So here we have 120 times 150. Here the vertical total is 150. You have 150 divided by the overall total. The overall total is 360 divided by 360. So if you do this very well, you should be having 50. You should be having 50. Similarly here, you have 120 times 75 divided by 360, the overall total. And that will give you what? That will give you, that will give you 25. Same thing, you repeat it for others. So here we have what? Here we have 150 times 135 divided by the overall total, which is 360, and if you do that very well, that will give you 56.25. That will give you 56.25. Similarly here, this gives you 150 times 150 divided by 360, which is the overall total, and if you do that very well with your calculator, that will give you 62.5. Similarly here, you have what? You have 150 times 75 divided by the overall total, which is 360, and that will give you 31.25. So let's repeat the same thing here. Here we have 90 times 135 divided by 360 divided by 360. If you do that very well, that will give you 33.75. That will give you 33.75. Similarly here we have 90 times 150 divided by 360, and if you do that very well, that will give you 37.5. Similarly here, we have 90 times 75 divided by 360, and if you do that very well, that will be giving you 18.75. So we've been able to derive all our expected values. Then you can now decide to compute our chi-square. You can decide to compute our calculated chi-square. If you're given the critical value, so you are comparing the calculated chi-square with the critical chi-square. So here we have, you can record the formula expected value all squared divided by the expected value divided by the expected value. So here we can see we have getting all our expected value. Here we have 45, we have 50, we have 25. And mind you, we are asked to determine the what? We have to test for the independence between ability in math and his or her interest in what? In statistics. In some cases, in some questions, you can be asked to determine the ability in math, to test for the independence in ability in math for people having low ability or people having average ability alone or people having high ability alone in some cases. So please take note of the question, read the question very well and understand it before just moving into the question, into the solution. But in this situation, they were not specific. They just told us to determine, to test for independence in ability in math and interest in statistics. So in this situation, we will be considering all the expected value in the table, all the expected values in the table. So now let's begin to complete that. Here we have solution means addition. So for the first one, our observed value is from the initial table you were given and not from this table. So the initial table you were given for this box, our observed value is what? Our observed value is 63. Don't forget, our observed value is 63. So here we have 63 minus the expected value, which is what? Which is 45 minus 45 squared. Don't forget the numerator. The square only affects the numerator divided by the expected value divided by 45 plus, for this box, what is our observed value, which is given in the initial table? Our observed value is 42 minus the expected value. The expected value is 50 squared divided by what? Divided by 50. Divided by expected value is 50. Plus the next one, which is what? From the initial table you were given, that's your observed value, which is what? Which is 15. Which is 15 minus the expected value, which is 25 minus 25 squared divided by 25 plus, we move to the next one. The next one here is what? From the initial table, the value there is 58 minus 56.25 minus 56.25 squared divided by what? Divided by 56.25. When you get to this point, as you can see that the values are very much. The values you're computing are very much. So you might not necessarily need to compute for everything in the table, because even when you want to finalize with your calculator has some a certain limit. Not all calculators can take everything here. As you can see, here we are having how many? We are having about 9 to compute here. So it's not all calculators that will be able to take that much. So since you've done about 4, and you can also get here, you can just go to the last one here. But please make sure you indicate that that's not everything. So you can indicate about 3 dots. You can use 3 dots to indicate that there are some hidden values there. Then you just say plus, hidden dots. You can just say plus the last one here, which is what? Which is, from the table, the last observed value is 29. So that will be 29 minus 18.75 squared divided by 18.75 divided by 18.75. So you can compute that using your calculator. You can compute that. So when pressing everything in your calculator, just ignore these 3 dots and move to the last value here. So if you do this very well with your calculator, you should be having 63 minus 45 squared divided by 45 plus 42 minus 50 50 plus 15 minus 25 squared divided by 25 plus 58 minus 56.25 squared divided by 56.25 plus the last value, which is 29 Here we have 29 minus 18.75 squared over 18.75. So this gives me 18.08. Excuse me, 18.083. 18.083. That means that your expected chi-squared, which is what is equal to 18.083. But don't forget that critical chi-squared. So recall that critical chi-squared in which you were given. The critical chi-squared in which you were given is what is 13.277. 13.277. So you can plot the distribution for that critical chi-square you are given, which is what 13.277. It will fall in the positive part, your distribution is symmetrical. So this should be around here, which is what? Which is 13.277. So you'll be shading this aspect. So now let's check. Is our calculated chi-square, does it fall within this region? You'll be rejecting this region. If it falls within that region, you reject your what? You reject H0. So let's check, does it fall within this region? This is 18.083. It is after 13.277. Definitely it falls within this region. So since S squared is greater than critical S squared, therefore H0 is what? Is rejected. That is, your H0 is that the ability in mathematics is independent of interest in statistics. So since that hypothesis is rejected, then what will be our conclusion? Our conclusion is that ability in math is dependent. That is, ability in math is what? Is dependent of interest in what? In stats. And that will be our conclusion to that problem. So this will bring us to the end of this particular lesson. We'll be moving to other lesson of this course in the subsequent videos. If you're new to this channel, kindly make sure you subscribe, you like, and share the videos with some of your colleagues who are also going to find it helpful. Tutor Bosun is here.